I'm going to solve the methods in a array list assignment. We'll start with this one here. We take the sum of all even numbers. So we've written a lot of code like this for arrays, basic sum counter method, right? We haven't entered anything yet, so we'll start our sum at 0. We'll loop through to every number. We'll ask if it's even, and when we're finished, we'll return it. So this is a great opportunity to check out like an enhanced loop. With enhanced loops, because of auto unboxing, we could either use a wrapper class integer here or a primitive int. It wouldn't really matter. We're going to take the numbers from the array list. And at this point, it's really no different than handling an array. So in fact, if you used enhanced loops with arrays, you'll hardly notice any difference at all with this code. So we'll ask if the number is even. And if it is an even number, passes that test, we'll go ahead and add it to the sum. That should actually do it. So it's like I said, if this was an array called Arraylist or ARR list, we would have done the exact same thing. So enhanced loops are great because of their versatility. The mystery method, we're not going to be able to use an enhanced loop. And the reason is we're going to be actually adding numbers into the array list. So 13s are split. So that's one number, whereas it's going to become two numbers. So that's going to require us to use the add method. And so one of the things we saw in our notes was that anytime you're adding or removing, you should not use an enhanced loop. So I'm going to go back to a traditional loop here. This is a void method, so I'm not looking to return anything. Since I'm not looking to return anything, I don't have to build a sum variable or anything like that. We'll walk all the way across the array. You could definitely make a case here for a backwards loop. So the backwards loop would be nice when I do try to insert this 1 or 3 when I split the 13. I'm going to have to do something with my index. So I'm going to start with a traditional loop, and then we'll look at maybe some problems that might arise, and we'll talk about how to fix them. So there's kind of 3 questions going on here. This time, unlike the last method I did with you, since I could not use an enhanced loop here, I'm going to have to use the get method to actually pull a number out of the array. And then once I do, I'll ask if that number is even. And if it is, it says I'm going to double it. Now, you could do this a few ways. I mean, technically, you could remove the number and add in a double of it. However, just point out to you, the best way to do this would be to use the set method. So part of the reason I wrote this problem for you is so that you could use the set method. So at index I, we're going to take that number and double it. In fact, we're going to use this number more than once here. So it might be a good idea to just go ahead and initialize a variable to hold that number for us so we don't have to keep getting it over and over. And now I can actually just reference X here. And right here, I'm going to take and set double X. Okay, so that's going to replace. Remember, the set method is really like your replace method. So we're going to replace the current value with twice what it is. Now, the number could have also been an odd number. So it's going to be a little tricky. We're also going to have the 13 here in a minute. So I could just write else here, okay? But let's just see what happens right now. With this, we're going to set it to 0. So at index I, we're just going to put in an actual 0. This would address everything except the 13. Now, one thing I got to be careful of is 13s aren't even, and they're odd. So even if I had put an odd check here, so ultimately we should be checking for this 13 first, just like we learned with our Java bats, right? Anytime you're looking out for some sort of exception, you should always handle that first. And then I'm going to go ahead and change this to say else if. Now, also with this 13, I'm going to be doing more than one thing. So I'm going to brace it. One thing I'm going to do is if I find a 13, there's a few ways you could do this. Okay, maybe you want to add a 3 and then set to 1. Maybe you want to remove the 13, add the 3, add a 1. Maybe you want to, I don't know, add the 1 and then set it to 3, whatever. So I guess there's a few ways you could do it. But I think what I'll just go ahead and do is I'm going to set the 13 to be a 3. Okay. And then I'm going to do pretty much the same exact thing, but I'm going to call the add method. And when I add, I'm going to add a 1. Now that's going to also do something else. That's going to move the 3 over. So the 13 became a 3. Then I put a 1 there, which caused the 3 to move over. The one last trick is I don't want that 3 to turn to a 0 in a future iteration of the loop. Okay, so to avoid that, I'll put an I++. Now, another way I could have handled that was with a backwards loop. If you correctly used a backwards loop here, you wouldn't have to put in a corrective factor because you would actually move away from the inserted 3, so it wouldn't be an issue. And you could have also done a while loop and taken control of it that way. But just goes to show, anytime we're adding or removing, we have to put some thought into, how those steps through the loops are going. And if you still don't see it, I'd say, try to trace your way through this array list, write out the indexes and see if you can trace through the status of the array. Maybe even put a print statement down here that says like system out print line ARR list, so you can kind of track the changes every step of the way if you really have a hard time seeing what's going on here. All right, let's go to ends in X counter. All right, so again, basic counter method. Okay, we're just gonna have to practice our array list syntax a little. And again, this would be actually a great enhanced loop. Once we get it to an enhanced loop, we can, just like before, just kind of treat it like it's an array. So this is going to hand me the string. If I have a string, I can get the last letter from it by substringing it. And once I have that last letter isolated, I'll do dot equals to see if it's an X. So s dot substring s dot length -1, that's my last letter. Okay. Does that equal an X? There's actually a method called equals with. Some of you may have learned about doing Java bats, but we never emphasize it because it's not part of our subset. All right. So isolate the last letter, see if you get an X, count it. Name of oldest person. Okay. Now this is a little tricky. We're obviously going to have to go into this person class. A person has an age and a name. And sure enough, they have a get name method. But you got to remember, the array list holds a person. So I can't get the name of the array list. That's probably like the most common mistake I would see a student make here. Okay. So, but what I can get is the name of a person from the array list. If you use an enhanced loop, it will get the person from the array list for you, making this problem easier. Okay. And then you could track the person. However, if you're doing an index tracker, it's a little bit more difficult. So I'll show you both solutions, and then you can kind of decide what you like. Okay. So if you were going to do an index tracker, which, we've seen how the index tracker is very versatile. So it works out just fine here. Okay. I'll go ahead and write my index tracking loop. And I don't know why I wrote I twice. That was kind of silly. Let's do this. Okay. And then let's start I at 1. We've already considered index 0, and we're going across the array list. We're using our size method now. Okay. Did I do that earlier? Yes. Okay. All right. For a minute there, I thought I did length. All right. Let's see. Okay. All right. So here's kind of that trick I was talking about. You have to understand that the array list holds a person. Okay. So if I go to the array list and I use the get method, that gets a person for me. You can't do get name directly on the array list, okay? Because get name is not an array list method. Get name is a person method. So now I could get the person's name. I have to take that person reference that I just got from the array list, and now I can call the get name method out, and that takes it all the way down to a string. You could do all that at once. You could write ArrayList.getI.getName, and you'd be holding a string. Okay. Now, I don't really need that string is another thing here. And in fact, if I create a string here inside the loop, it's not going to follow me outside of the loop. So I don't really need this because I'm actually looking for the oldest person. So maybe it would have been better for me to have gotten like this person's age. So I could use the get age method. So even though I'm going to look to return their name, since I'm tracking the index, I don't really need to know their name right now. It'd just be one more thing to keep track of. This is what I'm really interested in. Did I just find an older person than who I thought was the oldest? Now, who is the oldest person? Well, to answer that question, I would go to the array list. Now, remember, you can't get the age of the array list. You have to first get a person from the array list. Then you can ask for their age. This is no different than arrays. I don't want you to think like array list is making this hard. The difference is if I was working with an array right now, I wouldn't have said dot get index. Instead, I would have just said bracket index. So it's the same principle. Like you still would have had to have pulled the person out of the array list. It's just the syntax would have been different. Okay, so this is what it looks like with an array list. And from here, if that was the case, okay, the only thing I need to do is swap out my index, all right? Because remember, that's all I'm really interested in tracking. And since I'm using the index here as my point of comparison, as long as I have that variable updated, I don't really care about the other stuff, okay? The trick is when I get to the end, I'm not looking to return the index of the oldest person, okay? I'm also not looking to return the actual person, which, we've done that before. Instead, I'm looking to return their name. Okay, so here's where I'm actually going to use the get name method. So I'm going to use the index that I was tracking to get the person. Okay, this represents the oldest person, but the method, this is tricky. It wanted a string return, so I had to extract the string from that person. Okay. And I said I was going to show you an enhanced loop. All right, let's do this again. Okay, so let me turn that off. And it's actually, it's going to be a little bit cleaner, this code. Okay, so if I'm tracking the person, I'm going to call them old. I'm going to go to the array list and I'm going to take the first person I see. Okay, right? That's, typically like our starting point. Now, when I get to my return, well, I'll write that in a minute. But here's the enhanced loop. The enhanced loop is nice because remember, the enhanced loop, you take a person directly from the array list. Now you don't have to use the size method. Now you don't also have to use the get method. Okay. So we'll just go ahead and take the person that came out of the loop and we'll get their age. And we'll ask if it's greater than, remember earlier I created a person reference called old. Okay, well, what was that person's age? And if I find an older person, I'll swap these person references out. So now the person in the loop that was older is now stored in the variable I called old. When I get to the end, I should have the oldest person. I don't want to return that person. I want to return their name. Okay, and I can call get name on any person reference, which is what I'm holding. So you can see, quite a bit cleaner. If I don't do that, quite a bit cleaner code here. All right, a little bit less. Okay, but they both work. They both work. So whatever you like doing is fine. All right. And then this looks like the exact same thing, right? Except we won't put the get name method on at the end. So we're still getting the oldest person. The only thing I'm going to do differently, and I could do this with either method. So here, why don't we try out our index one? Okay. I'm just not going to take that last piece where it says get name. All right. So right here, I think I'm going to need a semicolon. And yeah, as long as I don't get their name, should be good. Okay. And the letter chopper. All right. So return an array list of type string that contains all the letters of the parameter word. Each letter should become an individual string. So they give me a string. This is what they give me. And I have to give them this. Part of the trick is we don't have this yet. So there's no instance variable that like belongs to this class that I can call on. And they didn't hand me one as a parameter. So I think for the first time, right, on this assignment, we're going to have to make our own. All right. And, whatever you want to call it is fine. But it's a new array list of type string. And we're going to the Arraylist constructor. That's why we put those parentheses there. Arraylist is a class. It has a constructor. And we're actually calling on that constructor. Right now, if I stopped, it would return an array list of type string, but it would be empty. There'd be nothing in it. It'd be size 0. I need to create the array list. And I'm going to do that by walking through the string. If this string has 10 letters, I want to loop 10 times. Okay. So I'm going to go to every index that belongs to the string. So this is going to be less than word.length. And remember, that is a string word. So I'm going to put the parentheses there because that's a string method. Okay. What I'm going to do is I'm going to create a substring by taking one letter of word. Okay. And I'm going to go I plus one. And then if I have a string and I built an array list capable of holding strings, I can call on the add method and add that string to my array list. The only thing that can go into chop is a string. I have a string. I created a one-letter substring from the word, so I can now add it to my list. Sometimes students get scared. They think, oh, it's going to go out of bounds. But remember, substring is kind of a special method. You can go one past that last index in substring without going out of bounds. Now, I typed a lot of code. There's got to be some errors here, so don't laugh at me if I made some mistakes. Let's see. Oh my gosh, it ran. All right, let's see. Okay, so let's look at letter chopper. We just did that one. Should return Brian. Oh, okay, got Brian. Should return Joe 55. Cool. Okay. Should return Joe. Got Joe. Should return four. Four words that ended in X. Let's see the mystery method. Oh, yeah. See how it did that? It split the 13s. The list actually grew in size. We see some zeros from the odd numbers, and all the even numbers got doubled. Looks like a perfect return. And sum all evens, random ints, check your own answer. Oh, okay. We got to check it ourselves. So 4 and 6 is 10, 16, 20, and 16, 36. I like it. All right. Looks good.